Good morning, mathematicians. It is the freaking weekend. Baby, I'm about to have me some fun. Uh, yeah, we're not doing spectral sequences. We're not starting life. A lot of things we're not doing today. But one of the things that we're not doing is we're not programming. We're not writing the code in Sage. So, just woke up. Well, just in time. The lecture is just in time. Rise and shine. Yeah, we're doing Sage shit today. That's what we're doing. So basically, let me explain what I've done. Let me explain what I've done here. So basically, I don't know, maybe there's implementations of this already, but I was like, it's just easier to write my own code. So basically what I've done here is I'm trying to compute all the cohomology groups. Turn this on. Thank you for that, Arad. Yeah, so basically, I'm looking at the Klein 4 group, acting on the group with two elements, and eventually I want it to be the elementary, the Klein 4 group acting on the elementary abelian 2 group. But this is step 1. And so basically what I did is I made a list. But I should change this. I think I made it 1, 0. Yeah, I should make this a 0, 1 list. There was reasons why it was different before. Oh, and I don't want this to be times now. I want this to be an additive notation. Yeah, yeah, I did define the Klein 4 by hand, which is maybe not ideal, but I don't know, because there's just weird things because like the thing is Sage will implement a group in a certain way, right? And so yeah, I don't know. Maybe this wasn't the best way to do it. But I feel like this way is great for me though, because I understand every single part of it. Yeah, down to its atomic elements. Here's the stupid. I hate when. I should really be working offline, but I need to install. I need to install Sage on this computer. Let's see. I gotta think. Think about my next videos. 21st, 28th. Okay. Recently, you tried using Sage for the first time, though couldn't really figure it out. Probably worth another shot. I'm surprised you had that experience, Arad. Yeah, you're a smart cookie. What were you trying to do with Sage? And these are particular kinds of. I'm not going to explain why I need this to be true, but I will. Wait, is that what I need to be true? Oh, I'm going to skip this condition now, actually. Oh, but I need something else. Maybe I should have kept it as 1 minus 1. What do I think about taking an introductory topos theory course as a second-year undergrad? Probably not a great idea, I would say, if you're taking it for marks. The thing is, it'll be very hard to understand. It'll be very, there's just a lot of like intuition and experience I think you'll be lacking. But then again, I don't know. Yeah. I think maybe taking it from marks is not ideal, but I'd encourage you to sit in on the course, all right? And then that way, and give it a good, honest try to stick with it and understand. But then that way, if it's like, okay, this is too crazy, you're not hurting your grades. You just feel mixed about high-level languages that try to put all the programming under the hood. Though it does have a lot of libraries which are useful, absolutely. It was the craziest, most memorable exercise I was given during coursework days. Probably, the Kuratowski's 14 operations. Definitely not the craziest exercise, but it's a cool one. Yeah. It says that there's a maximum of 14 sets that can be generated by repeatedly applying complement and closure. Yeah. And so for our homework in topology, we had to figure out, basically we had to prove it and exhibit all 14 things. So that was a cool exercise. You wanted to compute some kernels of homomorphisms between unstable Steenrod algebras. All right, what's a Steenrod algebra? And does it have... I know that those are kind of famous things, so... I imagine that they're implemented in Sage. Oh, look, yeah, Steenrod algebra comes up right away. So in terms of computing the kernel, like what, you want an explicit basis or something? Do I know any natural proof of the simplicity of psi NF? What is psi NF? I don't know what psi NF is. Simplicity of... Oh, sorry. PSL NF. I don't know. I don't know if I've ever seen those proofs. So, proof that PSL and double transitivity on projective space. Proof outline. Show that the stabilizer is maximal. PSL and Q acts doubly transitively on projective space. Meaning its stabilizer subgroup for a point is maximal, so that the group contains a transvection. Well, let's see what Stack Exchange has to say. Yeah, some things in math are just hard sometimes. How is it proved before Iwasawa's theorem that this is simple? You may just outline the proof. No one answered. Okay. Presumably, the old algebraists just proved there with their bare hands that normal closure of any non-trivial element is the whole group. Unenlightening. You were given an exercise to show that you can cover the unit square with a collection of lines such that the collection has the two-dimensional Lebesgue measure of 1. The collection of lines cover the unit square with a collection of lines. And somehow, how are you putting a measure on the collection? Hello, On Peace Music. I'm doing well. On Peace Music, what are you about musically? I've been playing piano lately. Learning some Chopin, learning some Satie, learning, trying to transcribe Better Off Alone by Alice DJ. If you were Boris, you'd look into some books on finite simple groups of Lie type. If this was Boris, well, remember, this isn't actually Boris. This is Boris Alt. Don't you know? If you take the union of all the lines. Really? You can cover the square with a collection of lines, but the union of those lines has dimension 1? In such a way that the union of those lines has dimension 1? That's weird. That's a freaky result. For real. How do you even do that? Like the two things I think about measure 1. Oh, sorry, I thought you said Lebesgue dimension 1. Oh, Lebesgue measure 1. I see. Well, I mean, that seems, wait a second. Then yeah, don't you just take like either of the obvious, like you just take all these lines until it fills up a square, or maybe you take you just rotate a single, oh no, that's not gonna, that'll make a circle, but yeah, wouldn't it just be this? Like you just take all of these, the union of all of these lines? Maybe I'm misunderstanding. That doesn't sound too crazy. You're a drummer. Oh, I've played drums in several bands. I was never that great at it. Definitely better at other instruments. Infinite lines? Now I really don't understand. Mainly play alt rock, but I also love funky stuff or Fusion too, though Fusion is super hard. Has Fusion got like crazy time signatures in it? I haven't listened to much Fusion. But you mainly make electronic music. Oh, more on the heavier side. Cool. Cool. Yeah. Oh, hey. Here we go. The GOAT. The absolute GOAT of useful math exposition. Keith Conrad here to prove why PSL is simple. But definitely this proof doesn't look so simple. Simplicity of PSL for n bigger than 2. Yeah, nice. Very nice. Well, there you go, Boris. There's your solution. The answer, I should have known. The answer is just go look at what Keith Conrad has to say about it. You mean lines, not line segments. I see. Okay. I see. But how is that possible? Because now, like, if you have a square, you take a single line, the line has, it's the two-dimensional measure. I see. Okay. I'm with you now. Yeah. Okay. Freaky. That is freaky. You saw this cool qual question recently with a beautiful let f be analytic on the deleted unit disk. And suppose in the same region it's also L2 with respect to planar Lebesgue measure is 0 a removable singularity. So what is it? So F is analytic on the disk. Well, wait. On the lead. Wait. What do we mean by analytic here? Are we talking about like punctured? I like this, right? Because you know how we like write hat for this. So I like writing this notation. I like using notation like puncture to mean r minus 0, right? Because it's also like, you know, in this one it's like, oh, it's wearing a little hat, like it's been completed. And then here it's like, oh, it's being stabbed by this little thing, like you poked out no punctured origin. Okay. So it's just on the disk. So what did you mean by what do you mean by the deleted unit disk then? What else could you mean by the deleted unit disk? The proof ended up utilizing the digital sundial lemma and some stuff related to the Kakaya sets. Very interesting. How many hours of math do I do a day? I have no idea. How much would I recommend? 25 hours of math a day would be my recommendation. I don't know. Also depends on where you are in your career. I'm an obsessive, so I just do math all the time. But when what was I gonna say? Yeah, I just do math a lot. But then yeah, I don't know. Some days I do very little math. Other days I do nothing but math. It's very hard to say. Very hard to say. And also, like, what counts as doing math, you know? If I'm, like, walking to the grocery store and I'm thinking about math, am I doing math then? That's not as productive as being in front of the computer and doing math. So I don't know. You make R angry to remove the origin? Yes, exactly. Digital sundial lemma sounds cyberpunk. Hell yeah. You mean it's on the punctured unit disk? Wait, but then... Oh, I misunderstood your thing. Okay, yeah. Okay, but this is just real analytic, right? Are we just talking real analytic? What do we mean when we're saying analytic here? A punctured disk viewed as a subset of R2? Hello, Kostaka Corey. You ACC optimize? I don't know what that is. Optimize it so you can do 27 hours of math a day. Wow, these numbers are getting up there. I got to step up my game. So wait, what was the question? This function, suppose the function is L2. And the question is 0 a removable singularity? So basically, can we extend this function to the entire disk? Wait, what does that mean? What does it mean to say it's a removable singularity? I mean, complex analytic on the same region. Oh, it's complex analytic. I see. But now with respect to Lebesgue measure on that region is finite. I see. So, okay. Right. And we're also saying, right, when we say to ask if it's a removable singularity, right. Interesting. I have no idea. It's been so long since I've thought about these kinds of problems. Oh, abbreviation of actually. I see. Wait, why is it 2 C's then? Oh, if the contour integral there exists. Interesting. Right. Take the integral of f over z. Can we say something about this? If this is true? Yeah, I don't know. I haven't thought about such things in forever. What was the answer, Boris? Did you figure it out? Okay, I want to go back over to my code here for a second. I'm probably all reloaded, but now I need to do something that's going to set up figure out which of these functions are differences of a cocycle. So basically, what is it? So CG is a function of a single variable, and then DC will be a function of 2 variables. Oh, interesting. Wait a second. So F. Yeah. I guess I need to do a triple thing here. So CG is a function of a single variable, and then DCGH is G. You saw the solution. It was an old qual paper. It's removable. Yeah, but how do you do it? You write out the Laurent series at 0 and bound each AN with some very clever Cauchy-Schwarz. Okay. I probably would not have guessed that. Very interesting. Mind you, actually, no. I mean, probably if I sat here long enough, I would have done something like, yeah, write out the series, try to do some integral stuff. Probably have ended up on, having the idea to put some information, try to prove the constants must be 0, but it might have taken some time. Good morning, Tenacity. The CS part is pure bow, And you don't even like analysis? Yeah. A good proof is a good proof. What can I say? So this is supposed to be the trivial action. So this should be CH here. And then we're going to get minus CGH. And then we're going to get plus CG. And actually, God, maybe I should formalize this as the group 1 minus 1. Because I do need, okay, I'm going to go back and formulate this multiplicatively. So let me go back and change this back to 1 minus 1. So I'm going to go back and make this multiplication and make this a multiplication. Great, because I still want these. So let me also make another list called good functions. And let's just do good functions append f. That's what we want here. Is it a priori meromorphic? Yes, I think, yes, that was the assumption there, Leo. I believe. Quite an unexpected tactic, though. Your first guess is always to use some limit or the removable singularity theorem. I mean, maybe there's another way to do it. Wondering how you can immediately invoke Laurent series, but maybe that's close. Yeah, because it's supposed to be analytic on the rest of the disk. You just write it up and end up proving the series converges. Midway through the starting point. It's just the definition of the coefficients. Oh, converges at 0. Yeah. Okay, I gotta restart this project because I haven't visited the page for a couple minutes. That's annoying. Also, I should have had more food before I started streaming so that I'd be ready to jog right after stream. But I'm probably gonna need some more energy and then wait for that to digest. Life's hard. Let's see, did that compile? I should just be downloading Sage. I should just be downloading Sage and doing everything there. Oh well. Okay, so now I need to make all the... Is there any way to categorically detect free R modules in RMod? Is there any way to categorically detect free R modules in RMod? I'm not sure. Yeah, I'm not sure. I mean, yeah. There direct sum of the monoidal unit with itself. Yeah. Yeah. Yeah, I guess that's the way to do it. So I guess you could use that idea. To try and generalize the notion of free, right? You could say a free object in, I don't know what category you'd want this in. A monoidal category with byproducts, maybe. Yeah. In a monoidal category with byproducts, you define a free object to be Monoidal unit doesn't work if R is non-commutative. Tensor products may not exist. Right. Wait, HOM-RN is the same as forget to the n? What's forget to the n? You do know the forgetful functor on piece, though. You do. What's the forgetful functor? You just take a module and you just think of it as its underlying set. And you take a morphism of modules and it's still a set function. Then you're done. That's all it is. Yeah, non-commutative case. But the thing is, I wonder if there's some way, like, I wonder if there's some way, cause so tensor products won't exist in general, but you know, of course, R can be viewed as a bimodule. But then also, like, what does that mean categorically? You know? So, like, all, whatever, you know, Freyd-Mitchell, you can embed your abelian category into a module category, but then what's like, how do you, can you go back and interpret if any of those modules ended up being a bimodule? I don't know. Suppose you have an equivalence between C and R mod, and you only have information about C. That's a situation. I am a bimodule, Leo. That's right. Stay mad. Yeah. Interesting question. I don't know. I mean, part of me is inclined to think that maybe not. Because, like, the general context of a module is really the notion of you know, it's an abelian category. And in abelian categories, we can define projective objects in a totally categorical way. And yeah. Context, you want to show or give a counterexample for the category of Beck modules. What is that again? Is that just the, like, growth and decompletion or whatever? Beck modules. I thought I, like, gave a talk on this once, actually. I don't even remember. A Beck module, right. Yeah. So it's something like, yeah. An abelian group object in the slice category. The category of Beck modules over a group is equivalent to ZG. How do I see that from this definition? In a category with pullbacks, let A be an object. So this is in the category of groups. An abelian group object in the over category of G. Right. Wait, so if we have an abelian group object into G, Why is that? Oh, ZG mod. I see. Wait, have I written it the other way? It should be the under category, right? Right. Oh, right, it's G over C, isn't it? Because we want a homomorphism from G into A? No. Category is pullbacks. A is an object. Oh, yes. Okay. Yeah, it's the... Wait, no. Yeah, I'm confused. Yeah, it's the... So wait a second. Our category, so for group G, our category is morphisms into G. And we want an abelian group. We want, yeah, an abelian group object in this category. But why is it G into A? It's C/A. Doesn't that mean... I mean C/A, so C/G. Shouldn't that be this? Because isn't it the things over G? Maybe I'm just misunderstanding the notation. I mean, I think G into A makes more sense. G into A makes more sense, but... Why isn't there a link to slice category so I can absolve myself? It is the over category. Why am I confused? Okay. Wait, but then how do I I'm still confused at how to see this. Back modules for a group over G is equivalent to ZG. Because the G into A is given by the unit of the abelian group object? I don't understand. I don't understand. Wait, so is it the category... Is it the category of objects of maps into G or out of G? I mean, if C over G doesn't mean morphisms into G, then I'm going to quit mathematics forever. Equivalently show the category of Beck modules is monoidal over set. You've shown that this is equivalent to the category being equivalent to a module category. Interesting. Maybe that's what I should be doing soon, actually, is a reading category, is live streams for infinity categories. But I don't know, people have been asking me to return to spectral sequences, even though it's not as popular as regular office hours. So what do I do? What I don't know what to do. What are the most important notions in one category theory to read for a solid foundation in infinity categories? Limits and colimits and con extensions. No, you don't need... I mean, maybe monads could be cool, but you definitely don't need abelian categories. I mean, just go look at hello Christian. Where's oh no, that's right. There we go. Am I prioritizing popularity? Maybe. Maybe. I mean, I just got, I'm still not totally sure if it's a scam or not, but there is an email reaching out on behalf of Brilliant, and they want to make a 3-video deal. So, yeah. So, being a professional YouTuber would be pretty dope. So yeah, but anyways, if you look at this book, Infinity Categories by Marcus Land, I mean, the first chapter, I mean, this isn't a place to learn these things from, but there's like, you know, you can see the things that get used in the first chapter. There's like, okay, we have the Oneida embedding. There's stuff going on about limits and co-limits. What else is being used here? You know, adjunctions. Simplicial sets. So, I mean, probably not a bad idea to have a basic understanding of like simplicial complexes as used in algebraic topology. What else? Yeah, adjunctions, right con extensions. Yeah, left con extension, right con extension. Yeah, then there's some stuff about algebraic topology. So again, could be useful to know about the algebraic topology incarnations of these ideas. Yeah, and then here we go. And then section 1.2, we introduce infinity categories. So, depends on what you're trying to do. Actual prerequisites is simplicial sets. Most intuition is the same as one categories. Do I use lean? I have used lean in the past. Will I use lean again? Who knows? I did apply for a postdoc that's centered around using proof assistance, and so you bet your little butt if I get it, I will be doing a series where I reteach myself lean. What kind of videos? I don't know. They just want a 60-second ad read, and I get a bonus if the videos go over 11,000 views in a short amount of time. And most of my videos don't do that. So I need to figure out how to make that happen. Maybe another Vixra thing. I don't know how to make that happen. Like working in practice with infinity categories is more like, let's pretend it's a one category. Yeah. Do I have any experience with Hawkshield cohomology? Basically not. Wrong con extensions? What? Would I call math an empirical science like physics? No. Yes, but what about lean, the formal proof system? Is it a joke there about getting high on cough syrup or something? Empirical methods can be used to motivate trying to prove a theorem, though. That's true. Still wouldn't call math an empirical science. Yeah. So I don't know. I still don't know. Maybe I'll come back. Maybe I'll come back to spectral sequences. I was Googling this morning trying to find something to read, but I didn't. I don't know. I didn't find something that I was particularly interested in. Okay, now what are we going to do? let's go. I'm gonna make another thing, which is just, oh no, that's fine. So let's say I need to make another set of tuples here, which are going to be my functions, just functions from my Klein group into Zmod 2. So let's go, I don't know, I'll call them one tuples, I don't know. Wait, what? No, these should be, wait, why was the other one length 16? Now I'm confused. Hang on. These should all just be length 4. These should all be length 4. Right, because 16 was 4 squared. Okay. Classical, Hochschild, homology, or topological. There is physicality to some mathematical things. Busy beaver functions you can think of as an empirical thing. Yeah. Hello, Julian. Faust. Julian. So you could say empirically find out values of BBN and add those as axioms. Wait, what? What do you mean by that? Empirically find out BBN. Proving things about BBN even for small n are independent of ZFC? But then how could you empirically find out things about BBN? That makes no sense to me. And then what am I going to do? I'm going to define a new list. So let me call this MD. It's going to be a new list of functions. I'm going to go for F. Let's call it C. For C in one tuples. You can only do it for the terminating Turing machines. I still don't understand what that means, though. Because if you could do it, if you could compute something with a finite, some terminating Turing machine, then, I mean, isn't that within reach of ZFC? Oh, but you don't know which ones those are? Yeah, but, I mean, if you just run one and it finishes, like, I don't see how that is outside of ZFC. Because, like, imagine you just did the computations in paper. Like, those are just computations that you're doing that are, like, valid in ZFC. So, I'm not sure what's meant there. Anywho. For C in one tuples, what am I going to do? I'm going to make a new function. I'm going to make a new function called F. And how am I going to do it? For X in the Klein group, for Y in the Klein group. I'm going to do f dot append. Oh, and I guess I want to do this multiplicatively. But every element is its own inverse here. So actually I can just make it this. This This still reduces to making a new assumption of which ones don't terminate. I don't understand. I still don't understand. What am I doing here? I am trying to compute. Well, there's something else secret that I'm doing here that I'm not going to tell you about. But the part of this I can tell you that I'm doing is I'm trying to work out the group cohomology. I'm trying to have the computer explicitly spit out the group cohomology, explicit functions realizing the group cohomology of the Klein 4 group acting trivially on the cyclic group with 2 elements. Is there a reason I'm using Python? Well, technically I'm using Sage, which looks like Python, but it's secretly like C under the hood or something like that. Really slow. It's good enough for me. Good enough for me. Yeah. Actually, almost nothing I'm doing here. Yeah, pretty much nothing I'm doing except I guess I'm using the tuples tool, but that probably exists as well in Python. So I could just be doing this in VS Code probably. But whatever. You have to divine which Turing machines run forever. But again, like this doesn't make sense because how do you do that? Like how do you do that empirically? I don't think you can do that empirically. I don't think you can do that empirically in a way that wouldn't just that would be outside of ZFC. Because if you can do it empirically, which is to say you just run the program and wait till it terminates, and if it terminates, then like it terminates in ZFC. Yeah, Coffee Handle has the right idea here. The math backends of stuff like NumPy is written in C and C++ anyways. Yes, yeah. Sage is Python with libraries, yeah. Yes, if you can do Python, you can do Sage. There's like, you know, in Sage, in Python you might have to do double star, but Sage is, in Python you might have to do this, but Sage is slightly more mathematician friendly because you type this instead. So there's like minor differences. Because empirically, you can empirically get the number that the longest one runs in. I don't know. I still just don't agree, Leo. Like, if you can compute that it stops, then within ZFC it stops. And if you can program in any language, you can program in Python, therefore true. In practical terms, you cannot do this. Yeah, it just doesn't make sense to me. You can empirically get the number that the longest one runs at. I mean, if you can do it empirically, then you can do it in ZFC. Unless I'm losing my damn mind. Okay, what is this going to be? So this is going to be... Oh, maybe I should have called these G and H. Yeah, I'm going to call these G and H. So then this is going to be... Oh, sorry, this should be right. C at G dot index. Wait, no. At K dot index of X. No, sorry. Of H times C dot index. Times C at K dot index of the multiplication of G and H times C at K dot index G. Will that run? Maybe. I gotta restart the project. Okay, well, you can add an assumption that the continuum hypothesis is true, and you can have computable sequences to this. What? You can add an assumption that the continuum hypothesis is true, and you can have computable consequences to this. Okay, well, what do you mean by computable consequences? Like, if you assume the continuum hypothesis is true, then you can say that program X halts. That's interesting. I'm going to have to look into this. Okay, let's see if this code runs. Oh, wait, there's something else I wanted to do here. And then I was going to say, input error. Why is this an input error? Append. Yeah. That should be here. I don't know why I even put that there. And then if this all happens, and then if f not in md dot append f. Let's go. No, it's still wrong. Not subscriptable. Oh, this should be this should be square brackets here. And this should be round brackets here. You don't exactly like, just because something is computable doesn't mean that ZFC implies it. But how could it not? How could it? I don't understand how it could not. Like if I can compute that 2 plus 3 is 5 in some finite number of steps, then it's true. I don't know. Like, what is an example of something that you think is computable that isn't true? Like if I can do something in a finite number of steps, then it's true in piano arithmetic. It's true in ZFC. So sure, okay, I completely agree with you. If a computation doesn't halt, okay, so then I think we have a bit of a misunderstanding of what is meant by computable here. So I'm talking about terminating. So because you were talking about empirically verifying when something so I absolutely agree with you, right? That it could be that a program doesn't terminate, right? But if BB337 terminates in a finite number of steps, right? If it's a finite amount of computation, and we do that computation, then that was provable in ZFC. Like the general question of whether these all, terminate or whatever, is maybe outside of ZFC. But if you have one of these specific things, and you do the computation and it terminates, that's in ZFC then. So that it's not, I don't see how it could be empirically, I don't see how you could empirically resolve this outside of ZFC. Mass has solved a very big problem. Okay. I look forward to reading your paper on archive. Tell us the title when the paper is on archive. Your RA assignments got perfect grades? Wow, good job, Coffee Handle. But almost all your classmates said the proofs are unreadable. Huh? Should you email it in for proof review? I mean, if you want it to appear on the next episode of Your Proofs Are Trash, then yeah, email it in. Do you mean that ZFC might not be able to prove non-termination, even if there's no proof of termination? Yeah, so that I agree with. Okay, so if you're saying what Arad is saying, then sure. Yeah, ZFC may not be able to prove termination. Doing any derivation is also doable in PA. You can do whatever axiom set you want, and if you're writing it on paper, you can do consistent derivation system. You can simulate it in PA. I'm not sure I get that last point, but I think I agree. Yeah. See, did my code run? Oh, it ran. It didn't even get angry at me. How much stuff is in MD? Let's see. Okay, great. So now, in practice, you don't think you can do experiments to determine BB numbers. But then what do you mean by, that's why you always had square quotes around empirically. So, well, then what did you even mean by empirically? What do you even mean then by square quote empirically? Philosophically, you can say it exists. Like there is an answer to each BBN. Can we say that? And provably such answers lie beyond ZFC. Sure. I mean, I agree with all of that. You saw my video on Wildberger. Do I think I will ever write a paper using finitist constructivist methods? Oh, that's a good question. My training has not prepared me to do such things, but it's not impossible. I mean, there's certain things I've been thinking about that. Probably, I don't know. Like, there's something I'm thinking about at the moment related to the Sage computations I've been doing. That I think, strictly speaking, I don't think I would be careful to definitively write the paper that's like, make sure I never use law of excluded middle or something. But I think the content of the paper, I think everything in the paper could essentially be formalized in a totally finitist, constructivist way. Because, yeah, it's all like super duper computable. and we don't really doesn't have to end up dealing with like any infinite sets or anything. Yeah. If I find a small counterexample to something, I'd be entirely finitist. Yeah. Well, kind of depends though, right? Yeah. Small counterexample. Yeah. I mean, yeah. I mean, it's kind of weird, right? Like the thing is the setup for all of the stuff I do in Langlands is like super duper infinitist and non-constructive. But then yet at the end of the day, at the end of the Kasdan-Lustig hypothesis, you're supposed to get out something computable. And I've written code that actually computes stuff. So there's computable aspects to what I do. But I guess in order to make those computations meaningful, you have to be super non-constructive. Does anyone know an analysis equivalent of this channel? Well, maybe I just got to start doing more analysis on this channel. All of ZFC is finitist if you just think of it as a finite logic game. Well, is that true? I mean, technically, isn't the axiom schema of comprehension technically... I mean, if you accept the axiom of infinity, then doesn't the axiom schema of comprehension actually become an infinite list of axioms, technically? Yeah, maybe we should do more analysis on this channel. I don't know. Okay. We've been streaming for a long time. I'm gonna go. Time for second breakfast, as the hobbits would say. So we've all learned a lot today. We've debated and discussed, and yeah, who knows what kind of office hours or self-learning series I'm gonna have soon. High schooler wanting to go into math. Would I recommend getting into higher math? I'll have to answer this question in another episode because I'm taking off right now. But I don't know. Comment your question afterwards. Maybe I'll answer it there. So.